Hey, this is Mr. Hansen, and I wanted to this is the summing it up video, or the video that kind of reminds you of what we've learned. So first of all, what is a function? A function is a set of inputs that each input connects to exactly one output. And functions are rules that kind of help us predict what's going on in the world. And so when you have a pattern of numbers, and you can write a rule based on that pattern, you've made a function. So is a sequence a function? Yes. And what kind of function is it? So that's kind of what we're going to explore. Let's take a look at this first sequence, 5, 8, 11, dot, dot, dot. I'm going to go ahead and graph this. So the first term was 5, and then the second term was 8, and then the third term was 11. And you might notice a common difference of 3 there, so 14, we're adding 3, and then 17, and then 20. And there we have it. And just based on the graph there, you can tell that this function, or that it is a function. You could use the vertical line test. And then you could also notice that the function is a linear function. So any sequence with a common difference, any arithmetic sequence, is going to give you a linear function. Let's just take a look at other ways to represent this linear sequence. So recursive formula, a1 equals 5. First term is 5. Any term equals the term before it plus 3. Here we're just kind of taking an input, saying the previous term plus 3 equals the next term. So that's another way of looking at it, but also it's a functional approach. You're taking an input and you're getting an output out. Let's look at the explicit formula. Any term equals, well, we started with 5, and then we keep adding 3, and the number of times we add 3 is n minus 1 times. So a sub n equals 5 plus 3 to the n minus 1. If you put ace of 22 here, you would get 5 plus 3 times 21. And that's going to be 68. So you can find any again, you're putting in some important inputs, the common difference and the first term, and you're getting out how much that term is that you want. Okay, let's turn this into function notation a little bit. All you have to do here is distribute that 3, so it's 3n minus 3. F of n equals 5 plus 3n minus 3, and add 3 to both sides. F of n now equals 3n plus 8. And you might be wondering, where did we get the plus? Oh, did I do that right? I did that wrong. I'm sorry. 5 minus 3 is 2. 3n plus 2. So you might be wondering where we got the 2 from. Well, it's just really, if you look back at the graph over here, and let me do this with a different color. If you look right back there, it's the 0th term. So we kind of move back a term from the first term to give us a y-intercept. And there you have it. F of n equals 3n plus 2. In function notation, you know it's a function there. We've talked about it being a function here. We've talked a little bit about it being a function here. And also it passes a vertical line test on the graph. There should be no doubt in your mind this is a function, and more specifically, it is a linear function. So let's take a look at another one. 5, 10, 20. Let's go ahead and graph this one. And before we do that, you may ask yourself, is it linear, is it exponential, is it neither? Let's see what happens here. So at 1 we're at 5, at 2 we're at 10, at 3 we're at 20. What are we going to be at 4? Probably 40. And at 5 we'll probably be at 80. Let's see, there's 80. And then at 6 we'll be at 160, right about there. So it's kind of making a curve like an exponential function. And it looks like it's repeated multiplication, which is a good sign that it's an exponential function. So exponential functions, they start sort of increasing gradually or decreasing gradually, and then they pick up just like that. Okay, let's take a look at recursive formula. a sub 1, our first term is 5. And a sub n equals a sub n minus 1 times 2. So that's our recursive formula. It would give us the next term. We just take a look at a sub n minus 1, and we get a sub n. 2 times 20 is 40. And finally, our explicit formula. If we wanted maybe the 7th or 8th term, we could say a sub n equals, first term was 5 times 2 to the n minus 1. Let's just try the 7th term there. So a sub 7 equals 5, and we're multiplying by 2, 7 minus 1 times 6 times. So 2 to the 6th happens to be 64, and 64 times 5 is 320. So the 7th term, 320. Notice we're putting in an input here, putting in the 2. Actually, with this function here, the input is 6, and we're saying we times 2 by itself 6 times, and then times that by 5. So that's what's going on there. We do have an input and output. Okay, so let's see if we can figure out the function notation for this based on right here. What you can do is you can talk about the 0th term. So here's the first term. The 0th term is going to be 2.5, because that's half of 5. So you can just say a sub n, f of n, equals 2.5 times 2 to the n. And really all we did to get from there to there is we started with the 0th term instead of the first term, so this was half as much, but then the minus 1 wasn't in there anymore. So again, function notation, you put in a number for n, the number of times you want to multiply 2 by, and you're going to get out a number for f of n. Let's take a look at, and we decided this was exponential. So here's a question. This one also has repeated multiplication. Will it be exponential? I'm going to draw a little graph here. So the first term, -2. The second term, 4. The third term, -8. The fourth term, if we're counting by 5s here, this is -5, 5, 10, 15. So the fourth term would be 16 right there. You see how it's kind of pinging up, then down, then up, then down. And it doesn't make a smooth curve like the exponential function made previously. So it's still a geometric sequence, but it's not an exponential function. Let's take a look and see if we can figure out a recursive equation for this. First of all, a sub 1 equals -2, and a sub n equals the 1 before it. And what are we doing to get from -2 to 4? Well, we're timesing by -2. So times -2. An explicit formula. A sub n equals a1, that's -2, times -2 to the n minus 1. And if you wanted the 8th term, you could say a sub 8 equals -2 times -2 to the 8 minus 1, that's 7. And -2 to the 7th power is going to be -128 times -2. It'd be 256. Okay, so maybe a bit of explanation here. What is it that's making him go from negative to positive to negative to positive? It's that multiplier of -2. So when your multiplier is a negative number there, it's going to ping up and down like that, and it won't be an exponential equation. And if we were to write this in function notation, we just have to go one previous to that, so it would be 1. So f of n equals 1 times -2 to the n. And that's it right there. So I hope this helped you recognize that sequences are indeed functions, and that you can determine if it's a linear function or an exponential function If it's linear, it comes from an arithmetic sequence. If it's exponential, it comes from a geometric sequence. But there are some geometric sequences that aren't exponential when you have these alternating positive and negative signs. Hope this helps out a little bit. Thank you very much. Have a good day.